Hello guys, very quickly we are going to be looking at the top 20 questions on our second class, and that's the top 20 questions on atomic spectra. We're so excited. Oh yeah, let's go together. Ensure you get every singular thing here. One of the things that make you to know that men or this guy they follow me or this babe they follow is that you are getting this. And if you're not getting them, of course, these are the things you're going to see in your exam, please. So don't play with them. Let's go together. Ensure you get 20 over 20. We're so excited. Yeah, let's go. Look at the first question here. Question 1 here says, what is the definition of spectra? If I could define spectra, what is the definition? Option A says the color of visible light. Is that spectra? Option B says the range of wavelengths or frequencies of electromagnetic radiation. Option C says the dispersion of light through a prism. Option D says the absorption of light by a substance. So how do you define spectra? Now, we have established that spectra is plural. The singular form is spectrum, right? And have you gotten the answer? First is for you to get the answer. Pause, get the answer first. Okay, let's see whether you are correct. The definition of spectra is simple. Spectra is the range of wavelengths or frequencies of electromagnetic radiation. And that makes option B the correct answer. That's very simple and direct to the point. Look at question 2. In our question 2 here, we're given this lovely question. What is the characteristic feature of emission light spectrum? Of course, you have emission and absorption light spectrum under your discontinuous spectrum. What's the characteristic feature of emission light spectrum? Option A says bright colored lines against a dark background. B says dark line within a continuous spectrum. C says complete absence of lines. D says continuous range of wavelengths. Continuous range of wavelengths. Now, have you gotten the answer? Exactly the way we are going, like this, how you should go in the exam hall. In other words, you are not in a hurry. No. You are fast though, but you are settled to look at the answers and reason them out. What is the characteristic feature of emission light spectrum? I've explained this to you. Now we have absorption and emission light spectrum. In your emission light spectrum, what do you have there? What you have is a bright colored line against dark background. Bright colored lines against colored backgrounds. Why dark lines in continuous spectrum is your what? Absorption spectrum. Are you getting it now? So that makes option A the correct answer to this question. If you throw this away, man, I'll be angry with you, bro. Look at the next question, my guy. Question 3 says, in absorption line spectra, what causes dark lines within a continuous spectrum? Of course, you have continuous spectrum and then have dark lines coming in. In absorption spectra, what causes dark lines within continuous spectrum? Option A says reflection of light. B says absorption by light moving to higher wavelengths. I don't know. C says dispersion through a prism, and then this is ionization of light of atoms. Ionization of atoms. What's the correct answer? In absorption, of course, in absorption, what will happen there? Now, the cause of your dark lines within a continuous spectrum is that. Have you gotten your answer? Have you gotten the answer? Of course, in your absorption line spectrum, what happened? There is that movement. Are you getting it now? There is that movement from lower energy level to higher energy level. We have established that in your emission, as a rich man, start dashing your money. What will happen? You become naturally poor when you start giving recklessly out. You are emitting, right? As you are emitting, you move from higher energy level to a lower energy level. As a poor man or as a student, start gathering, packing things inside you. What happens? You naturally become intelligent. That means you are moving higher. Are you getting it now? From lower energy level to a higher energy level. So in absorption light spectrum, absorption, as you are absorbing from me now, what happens? Automatically you are increasing. You are moving high in terms of your knowledge. Are you getting it now? So in absorption light spectrum, what happens there is this. Electron, they move from your lower energy level to your higher energy level. And that's the cause of dark lines there. That makes option B the correct answer. You seen it now? Very simple. Look at question number 4. Question 4 here says, what is the primary cause of continuous spectra in white light? What is the primary cause of continuous spectra in white light? You know, white light will vibrate in an infinite number of planes, right? What is the primary cause of continuous spectra then? Reflection, dispersion through a prism, absorption by electrons, and diverse wavelength component. The primary cause of your continuous spectra in white light is simple. It is due to, have you gotten the answer? Have you gotten the answer? Hey, you are wrong. Diverse wavelength component is the correct answer. They have different components of wavelengths. Are you getting it now? So that's the major cause. I've explained this to you. The next question, question 5, says which series in your hydrogen spectrum is named after its discoverer, and is associated with transition to the first energy level? It's not just the name that you should focus on here now. You should focus more on the energy level there. And then we're given energy level N is equals to 1. Now, what's the answer there? Lyman series, Palmer series, Paschen series, bracket series, LBP, BP. That's the acronym I gave you. The first there, L, that's your Lyman series. And that is option A, the correct answer to this question. Look at question 6. In our question 6 here, what is the significance of atomic spectra? What's the significance? What makes atomic spectra to stand out? Option A says reveals the color of visible light. Option B says indicates specific energy levels in atom. C says it describes the dispersion of light. And D says it represents the absorption of light by a substance. Get this answer for me. What is the significance of atomic spectra? What is the significance of atomic spectra? Reveals the color of visible light. Indicates specific energy levels in atoms. Describe the dispersion of light. Have you gotten your answer? Represents absorption of light by a substance. Now go through it. Get it for me, bro. Get it. Get my guy. Get it. Main significance of atomic spectra is that it indicates specific energy levels in atom. That's why you have energy level 1, energy level 2. Atomic spectra is also called line spectra now, or discontinuous spectrum. That makes what option B the correct answer. Look at the next question, question 7 here. In our question 7, what constant is involved in the formula that expresses the wavelength of hydrogen spectral lines? What constant? Yeah, that constant. What is it called? Is it Planck's constant? Is it Avogadro's constant? Is it Rydberg's constant? Is it speed of light? What's it called? Of course, it is called your what? You are correct. Rydberg's constant, option C. Look at the next question, question 8. In our question 8 here, what is the process where white light separates into its component color when it passes through a medium called? That medium there could either be your prism or your water droplets. Ionization, reflection, dispersion of light, absorption. Is very simple. What is the answer? Dispersion of light. Look at the next question here, question 9. Why does dispersion of light occur in a medium like a prism? Why does dispersion of light go and occur in a medium like a prism? Option A is due to ionization of atoms because of a variation in the speed of light. Absorption of specific wavelengths, complete absence of dispersion. Now, what's the primary cause? Why does dispersion of light occur in the medium like a prism? Is it due to ionization of atom? Is it because of the variation in the speed of light? Is it due to the absorption of specific wavelengths? Of course, it is the variation in that speed of light. And that is option B, the correct answer. Are you seeing it now? Look at question 10. You are correct. Move with me, man. You are doing well. How many have you gotten out of the 9 questions? Wow, you are doing well. Follow me. Question 10 says, which color of light bends more when passing through a medium causing dispersion? Which color of light bends more? Which one will bend more? Option A is red, blue, green, yellow. Now, let me ask you a question. Do you know why you have to pause the class and ensure you are getting the answers first before I call the options? The reason is that's the only way you will ensure that you are really following. Oh yes, because in the exam condition, Sapira is not going to be calling the answer for you. Only you will be getting it yourself. So you will ensure that you pause, you get the answer, and then you flow along. That way you are giving me joy in my heart. Which color of light bends more when they passes through a medium? Which one will bend more? Don't stress yourself. Roy beam. This guy will bend more. So they are bending, their degree of bending. This is the highest bender. Are you getting? This is the least bender. So Roy Cliff just move direct. Now, is it red? Okay, red cannot be blue. This is blue, yeah. Oh, this is blue. This is red, yeah. Only you will choose it now. Green, this is your green, yeah. Of course, blue will bend more than green. And then yellow, no. What's the answer? Blue become the correct answer. So that makes option B the correct answer to this question. Look at the next question here. Question 11. Question 11 says, what is the primary difference between emission line spectra and absorption line spectra? What's the primary difference between them? Option A says emission spectra have dark lines, while absorption spectra have bright lines. B says emission spectra are continuous, absorption spectra are discontinuous. Okay, oh. C says emission spectra are produced by cooler gases, while absorption spectra are produced by hot, dense objects. Option D says emission spectra result from transition from a higher energy level, while absorption spectra result from transition from a lower energy level. Now, I don't know. Choose the answer. Have you gotten it? When you get the answer, let's go together. Pause. Okay, let me analyze everything one by one for you. Look at it now. The primary difference between emission line spectra and absorption line spectra. Let's start on option A. Emission spectra have dark lines, while absorption spectra have bright lines. Is that truly correct? That's wrong. It's the opposite of each of the other. Emission spectra have bright colored lines on dark background, while absorption spectra have what? Continuous spectrum, and then they have dark lines. B says that makes option A can never be the answer. B says emission spectra are continuous, while absorption spectra are discontinuous. That's also wrong, because both of them are examples of your what? Discontinuous spectrum. C says emission spectra are produced by cooler gases, so absorption, that cannot be the answer. D says emission spectra result from transition from a higher energy level, emission, higher energy level to lower energy level. While absorption, the result from transition from where? Lower energy level towards higher energy level. That is option what? D, the correct answer. Are you seeing it? You got it right? Question 12. In question 12, what does the hydrogen Balmer series involve in terms of N value? Balmer, LBP, Lyman series, Balmer series. I don't know. Option A is transition to the first energy level where N is equals to 1, transition to the second energy level where N is equals to 2, transition to the third energy level where N is equals to 3, fourth energy level. What is the answer? It's very simple. What does hydrogen Balmer series involve in terms of N value? Balmer is the second one. That's energy level N is equals to 2. That means option B, the correct answer. Simple. Look at question number 13. In question 13, how are atomic spectra related to the electronic configuration of atom? Atomic spectra, how do they relate to electronic configuration of the atom? Option A says atomic spectra have no connection to electronic configuration, structure. Nice one. Option B says atomic spectra reveals quantized energy level and the evolution of electronic structure. Option C says atomic spectra represent only the visible color of light. Option D says atomic spectra are a result of ionization process. Now, what was the correct answer here to this question? Now, only you pause, try get the answer. When you hear atomic spectra and their relation to the electronic configuration of atom, electronic structure of an atom, take note that atomic spectra, they reveal quantized energy level, quantized states. Are you getting it now? And the evolution of electronic structure. That means option B, the correct answer. Very simple. Look at question number 14. In question 14, okay, nice one. Calculate the energy change per mole of an electron undergoing transition from N is equals to 2 to N is equals to 1, given that H is equals to 6.626 and 10 to the power of minus 34 joule per second, and then Na is 6.02, blah, blah, blah. This is a very, very long calculation we're going to do here. But let's take our time. Before we see the options, let's solve this out. Only you try and solve it. They play. You don't even know where this calculation is coming from. Calculate the energy change per mole. So we have to get energy change per mole of an electron undergoing transition from N is equals to 2. So they gave two values of N. They say N is equal to 2 and N is equal to 1. Okay. Given that our Planck constant, you don't need them to give you value of Planck constant. Only you should know it. It's not every time that we give it to you anyway. That's your 6.626 times 10 to the power of minus 34 joule seconds, right? And then they gave N a Avogadro's number. What's Avogadro's number? 6.023 times 10 to the power of 23 per mole. That's the unit for Avogadro number. Avogadro number is in per mole, not mole. Per mole. Sure, I'm drawing your ear now. It's a constant exam question. Per mole. Now, what do we do when we come to this? It's very, very simple. Okay. You will use your Rydberg's equation to solve this for me. What's your Rydberg's equation? 1 over lambda, follow me, is equal to ROH into 1 all over n square minus 1 all over m square. So this is your Rydberg's equation. Let's start from there. So what is our 1 over lambda? 1 all over lambda, I'm going to get the value of lambda, and the 1 over lambda, everything about 1 over lambda, is it not wave number, and that's per centimeter. But I'm going to get my lambda from there anyway. That's going to give me my Rydberg's constant. What's your Rydberg's constant? They didn't give it to us. What is the value? Only you bring it out yourself. 109678, right? 109678 into 1 all over. I told you that where m is always greater than n. So if they've given us two values here, know that if I'm reading your ABCD, A, B, C, D, E, F, G, H, I, J, K, L, M, N, M is greater than N value. Are you getting it now? So don't play. So when your M value is greater than your N value, automatically the greater one is M. So this is M. You take it yourself as M here, and then this is N. That's going to give us 1 all over N, 1 all over 1 square minus 1 all over M. M is 2 square. Close your bracket. So 1 all over lambda is automatically going to give us 109678 into 1 all over 1 square. Now, just this is the secret here. Let me use here. 1 all over 1 minus 1 all over. What's your 2 square? That's going to give you 4, right? So what's the LCM here? 1 over 1 minus, this is 3 over 4 direct, but let me show it to you. LCM here is going to be 4. 4 into this is going to give me 4. Divide by this is going to give me 4. 4 times 1 is 4 minus, what do I have here? 1. And that's going to give me what? 3 all over 4, right? Oh, yes. So in exam condition, so this is a very constant question that you repeat. That's going to give me 1 all over lambda is equals to, of course, that's going to give us nothing but your 82258.5, right? Yes. So this that I've gotten now, hold on, let me explain. It is 1 all over lambda, and that 1 all over lambda is the same thing as my what? As my centimeters. So don't forget, your wave number is measured in what? In centimeter and per centimeter. So this is per centimeters I'm going to have there. You must understand something with me very, very fast, that this value that we have gotten here is in per centimeters, right? 1 over lambda. Now convert it from 1 over lambda to lambda itself. So if I'm getting lambda, that means I'm taking the reciprocal. That means I'm going to divide here by, there's going to be 1 all over whatever I have here. So lambda itself now is going to give me 1 all over this entire value. And that's going to be 82258.5. Are you seeing it now? So everything I'm going to have, don't forget that this is in per centimeters. So this still is in centimeters here. And that's going to give me, so use your calculator, divide 1 by 82258.5 and tell me the answer very quickly. With your calculator very quickly, this is going to give you 1.2157 times 10 raised to the power of minus 5 is what I'm going to have in centimeters. But I don't need my answer in centimeters. I want to work with meters. So for me to accurately work with meters, I need to convert this answer from centimeters to meters. So what is it going to give me? Of course, it's just for me to divide by 100, right? If I'm dividing it by 100, automatically it's going to give me 1.2157 times 10 raised to the power of 7 in meters. So I've gotten my wavelength. Now, hold on. Let me use 1 stone and key 2 bed. If they ask you to solve and get for wave number, calculate the wave number, you see this guy here, this automatically is the value of wave number. Are you getting me now? Don't play. So wave number is in what? Per centimeters, because this is 1 over lambda, and we have established that 1 over lambda is the same thing as your what? Your wave number. Don't forget that. So I've gotten wave number. If they ask you to calculate for wavelength, this automatically is the wavelength in meters. But that's not what they're asking us for. They're asking us to calculate the energy change per mole. So first, I'll get my energy. Now, don't forget that your energy is very simple. Your energy is nothing but A is equal to what? A is equal to H naught, right? Yes, H naught. Yeah, that's true. So if our E is equal to H naught, don't forget that your E, which is energy, is the same thing as your Planck's equation now. Energy here is the same thing as your H naught. What's your naught? No, now this is it. Follow me very squarely. Let me prove everything to you. From your V is equals to F lambda. Now your naught is the frequency, right? Yes. So your frequency here is equal to your frequency, which is equal to your V all over your what? Lambda. And your frequency here is your naught. Naught is equal to your V. What's your V there? C all over lambda. Are you following me step by step? That instead of me using no here, what will I better use there? I'm going to use C all over what? Lambda. So I'm going to apply this equation and get my energy. Energy is equals to HC all over lambda. Now, the question is this. Do I know the value of Planck constant? Yes, you know the value of Planck constant, H. Do I know the value of speed of light? C. Yes, your C, you don't need anybody to tell you. Your speed of light, C, is what? 2.998 times 10 raised to the power of what? 8 meter per second. That's your C. Now, do I know my wavelength? Yes, we have automatically gotten wavelength just now. What's your wavelength? Your wavelength, lambda, is equal to 1.2157 times 10 raised to the power of 7 in meters. So I'm going to apply all of these top parameters into this, and then we're going to solve it very shortly. Are you getting it? So follow me along. So very quickly now, you are going to discover something that, okay, our E here, energy, is equal to HC all over lambda, and that's going to give us our H. What's H? Planck's constant, and that's 6.626 times 10 to the power of minus 34 multiplied by C. What's your C? Speed of light, 2.998 times 10 to the power of 8. I'm going to divide it by my wavelength, lambda. And what's lambda? 1.2157 times 10 to the power of 7. Are you seeing it now? So use your calculator and multiply all of this together and see what your energy becomes. Now, automatically, this is going to give me my 1.634 times 10 raised to the power of minus 18. Now, energy, where is energy measured in? Energy is measured, of course, in joules, right? Joules. Don't forget that here is negative. This is negative. Oh, this is not 7. This is minus 7. So here is negative. Correct that negative there. Now, if I have this, energy is what I've gotten here to be 1.634 times 10 to the power of what? Minus 18 joules. Now, they say calculate the energy change per mole. That energy change per mole, they are asking you, if they ask you to calculate energy, please don't forget this is whatever you get as your energy. This is your energy. But they are not just asking us energy now. Energy change per mole. That means energy in joules per mole is what they're asking us. And now don't forget that your Avogadro's number is 6.023 times 10 to the power of 23 per mole. Per mole is all you have. So if I multiply per mole times joule, what will it give me? So just give me joule per mole now. Are you getting it now? So whatever you have as energy, multiply it by your Avogadro constant. If I multiply it, I'm going to have my energy change per mole. That's energy in joules per mole. That's what they're asking us for. That's automatically going to give us our energy is 1.634 times 10 to the power of minus 18 multiplied by Avogadro's number. What's Avogadro's number? Avogadro's number is your 6.023 times 10 raised to the power of your 23. So if I do this automatically, that's going to automatically give us our 984,158 in your what? Joules per mole. But hold on, let me show you something here very quickly. That's your joules per mole. Let me show you something here very quickly. You will see that if this guy is in joule per mole, your answer may not come in joule per mole. It may even come in kilo. So how do I place it in kilo? This is 1, 2, 3. So just look for 984.158 kilojoules per mole. So anything similar to this automatically become the final answer to this question. Are you getting me now? Look at this intriguing question number 15. The question here says that the characteristic of atomic spectrum are, option A, the spectrum is a line spectrum, atomical. B says the wavelength of spectral line decreases as frequency increases, atomic. Option C says, what did they give us in option C? The intensity of spectral line decreases as frequency increases. And then option D says all of the above. Now, what is the correct answer? Only you reason it out for me very fast. The characteristic of atomic spectrum are, number one, you know that atomic spectrum is a line spectrum. That's correct. The wavelength of spectral line decreases as frequency increases. That's correct. Intensity of spectral line decreases as frequency increases. That's also what's correct. Wavelength and intensity, they are decreasing at frequency is what's increasing. That's correct. So all of the above become the correct answer. That makes option what D the correct answer. But let me explain something to you so that you get it. Now, do you remember this when I was explaining it to you very quickly? You remember all of this, right? Okay. Lyman series, LBP, BP, Lyman series, Balmer series, Paschen series, Bracket series, P-Font series. If you watch one thing here, only you look at it now. Intensity, look at the intensity of this and the intensity of this. Are they the same or they are different? They are decreasing. Are you getting it now? As they are decreasing, what's their wavelength? Okay, look at, this is the wavelength. All their wavelength, the length here is decreasing. Wavelength is decreasing. Now look at intensity, the degree to which this one is covering here, and look at the intensity of this. Just be looking at their intensity to which they are covering. What is happening to it? Is it increasing or is it decreasing? It is decreasing. So what can we say there? Intensity and frequency, both of them are what? Decreasing, as the frequency is what everybody increasing. Are you getting it? It's as simple as that. If you understand this very quickly here, let's look at the next very fast question number 16. In question 16 here, line spectrum consists of dash wavelength, while continuous spectrum consists of dash wavelength. Now, very, very simple and direct. Line spectrum consists of continuous spectrum is different. Line spectrum is atomic spectrum or discontinuous spectrum, right? It consists of characteristic wavelengths. Line spectrum has what? Characteristic wavelengths. Don't forget that. While your continuous spectrum consists of all wavelengths, all wavelengths. Don't forget that's the answer to the 2. The next question, question 17, says that the significance of line spectrum is dash. What's the significance of line spectrum? It's very simple. This is it. Only certain energies are allowed for the electron of hydrogen atoms. Only what? Certain energy, line spectrum, characteristic wavelength. Only certain energies are allowed for the electron of hydrogen what? Atom. Now look at question number 18. Question 18 says, why is the line spectrum of an element sometimes referred to as fingerprint? Line spectrum is fingerprint because everything is unique on its own. The reason is this. This is because every element has unique line spectrum. Every element have a unique what? Line spectrum due to the different number of electrons in the atom. So different number of electrons in an atom give every element their unique what? Spectrum. Don't forget that. Look at question number 19. Question 19, calculation question. Calculate the frequency. Frequency, we don't know. Frequency, unknown. Calculate for it, we don't know. Frequency and wavelength, lambda, we also don't know. In the hydrogen spectrum that correspond to an electron traveling from n is equal to 2 to n is equal to 3. Okay, very simple. They said n is equal to 2 to n is equal to 3. Only you will know from your Rydberg's formula. What's your Rydberg's equation? Your Rydberg's equation is 1 all over lambda is equals to your RH into 1 all over n square minus your 1 all over m square. Very simple and direct. Now, again, I will always refer you to your V is equals to F lambda. You see, this equation are more like stopped. Now, what's your V? Your V there is C is equals to F. What is your F? No, right? No lambda. Calculate the frequency and wavelength. We can get wavelength from here, but frequency, no. What's your no? Sorry, what's your no? No is equal to what? C all over what? Lambda. So this is the equation we're going to use and get that. No is equals to C over lambda. Don't forget that. But let's get our lambda first. That's why it says calculate frequency and wavelength. You get wavelength first before frequency. That's going to give you, you can pause this class so that only you will get the answer for me. That's going to give us, what's our Rydberg's constant? 109,678 into 1 all over. We said that the largest value is m. So the largest value is m and m is 3 there. 1 all over n, that's your 2 square minus 1 all over 3 square. That's going to give you 109,678 into, that's going to give us 1 all over, what's your 2 square? 4 minus 1 all over, what's your 3 square? 9, right? So you're going to have that. So very quickly, this is going to give you, what's the LCM of these two? 9 and 4. LCM of 9 and 4, 18, that's 36 here, right? 36, this is going to give me 9. 9 minus, of course, 4 here. 109,678 into the whole of this. And that's going to give you 109,678 multiplied by 9 minus 4, that's 5 all over 36. When you use your calculator very fast to do this, you see, okay, if you solve the whole of this, just go direct. You know, this is your 1 all over lambda that is going to give you this, right? If 1 over lambda is giving us this. Now, just go direct, solve 1 over lambda and convert it to lambda. Lambda is going to give you 6.56 times 10 raised to the power of minus 5 in centimeters. So if this is my lambda, I don't really need it in centimeters. I need it in meters. So lambda is going to give you your 6.56 times 10 raised to the power of minus 7 in what? Centimeters. So we have gotten wavelength, which is lambda, simple. But we are to get what? Frequency. So how do you get frequency? Don't forget that your frequency, which is your known, is equal to C all over lambda. And that's going to give you, what's your C? C is your 2.998 times 10 raised to the power of what? 8, isn't it? Divided by your lambda, 6.56 times 10 raised to the power of minus 7. Whatever you have is automatically going to give you your no. So what's our no going to give us? No is going to give us, use your calculator and multiply this and see what the answer becomes. So this automatically is going to give you 4.57 times 10 raised to the power of 14. Now, since it's frequency, our frequency there, of course, the unit is what? Is so we're going to have this become the final answer to this. Are you seeing it now? Very, very simple. Ensure you go over this again and again and again. Now look at in 20 question number 20, which is the last question. Hooray, let's go. In our question 20, the question says, calculate the wavelength. 1. Number 2 is the wave. Okay, the first one is wave number. Number 2 is the wavelength. Number 3 is the frequency. Number 4 is the energy in joules. And number 5 is energy in joule per mole of an electron undergoing transition from n is equal to 2 to n is equal to 1. I've solved this question for you in number 14. Run to question number 14. Pause every bit of it and pick out all the value. Your wave number there, your wave number, which is the first one, is 1 all over lambda. Pick it out. Number 2 is the wavelength lambda. I solved it for you. Number 3 is frequency. Get the frequency yourself. Frequency there is nothing but your what? Your no. Are you getting it now? Use the idea of number 19 to get it. No. No is equal to C over lambda. No is equal to C all over what? Lambda. You will see the answer very, very easy and direct to come out. Number 4, the fourth one, energy. Energy. Where we use E is equals to energy is equals to your H. No, all over lambda. Of course, only you will pick out energy from there. That's energy that you get there is energy in joules. And the fifth one, they say energy in joule per mole, where we multiply it by Avogadro's number. Are you getting it now? So these are all the 5 things that you are going to pick out. I've solved everything there in question number 14. What does this signify to you? You see this question 14, question 20, the same question. They are always constant exam question that they ask every time, now and then. Are you getting it? So go through over this again and again and ensure you get every singular thing from me. Enjoy. See you in the third class very quickly. Bye-bye.